how do you distinguish between an entity that is thinking and one that is simply mirroring the words you want to hear? Our drive for digital companionship existed long before we had the hardware to support it. In 1966, MIT researcher Joseph Weizenbaum created ELIZA, the world's first true experiment in machine-human conversation. As this terminal screen shows, ELIZA did not possess a mind. It operated through basic pattern matching. If a user mentioned their mother, the script would simply invert the sentence and ask, "Tell me more about your mother." Despite having no agency of its own, ELIZA was a profound success. Users became deeply attached to the program, proving that humans will project intelligence onto a machine, even when that machine is doing nothing more than reflecting their own voice back at them. In the decades following ELIZA, AI remained strictly reactive. It existed in a state of permanent dormancy, unable to take a single step without a human initiator providing the first prompt. By the early 2000s, millions of users were interacting with Smarter Child on platforms like AIM. It was more accessible than ELIZA, but the mechanical reality was the same. It was a rule-based retrieval system, fetching weather and sports data through pre-written scripts. This dynamic entered our pockets in 2011. When Siri debuted on the iPhone 4S, it asked the same fundamental question that Amazon's Alexa would ask years later: "What can I help you with?" The machine was now listening, but it was still waiting. While the hardware integration was seamless, the logic followed a closed loop. A human gives a command, the system retrieves a specific piece of data, it speaks the result, and then it stops. These agents had reached hundreds of millions of homes, yet they were trapped in a state of total dependence. They could speak, but they could not independently reason. For AI to advance, it had to move past simple retrieval. It needed the capacity to navigate complex, unstructured environments, a transition that began with raw mathematical strategy. In 1997, IBM's Deep Blue defeated Garry Kasparov, the world's leading chess strategist. It was a milestone for brute force computation, proving that a machine could navigate a massive tree of possibilities faster than any human. In 2011, IBM Watson applied this processing power to Jeopardy, interpreting the nuances of human language and puns to defeat the game's greatest champions. Watson proved that AI could analyze millions of documents in real time to reach a logical conclusion. But calculating every possible outcome only works in games with fixed rules. To truly mimic human intelligence, machines needed something more difficult to program: intuition. The game of Go has more possible positions than there are atoms in the universe. In 2016, DeepMind's AlphaGo navigated this near-infinite complexity to defeat world champion Lee Sedol, demonstrating that AI could develop its own creative strategies that often baffled human experts. This sequence of victories built the foundational AI brain.
Machines had moved beyond simple pattern matching to outthink humans in strategy, language, and high-stakes decision-making. In 2018, Google Duplex demonstrated that this reasoning could successfully move into the real world. During a live phone call to a hair salon, the AI successfully navigated an unscripted conversation, even including human-like hesitations to facilitate the booking. The release of ChatGPT in 2022 democratized this general reasoning. Large language models could now write code, solve logic puzzles, and synthesize vast amounts of information for anyone with an internet connection. This created a new archetype, the Oracle model. This is an entity with a comprehensive map of human knowledge that outputs incredibly sophisticated data, yet remains isolated from the tools it describes. The Oracle can write a detailed plan to reorganize your workspace, but cannot open a folder. It can advise, but cannot execute. By the end of 2022, AI was a brilliant but paralyzed mind. It possessed the reasoning capacity to solve complex problems, but it lacked the digital hands required to interact with the world. In 2023, the architecture of these systems shifted. Developers began connecting reasoning engines directly to local environments, allowing software to begin executing its own multi-step objectives. This was made possible by the loop. Projects like AutoGPT allowed an AI to break a high-level goal into a series of tasks and then prompt itself repeatedly to finish them, eliminating the need for a human to manage every single step.
By 2025, agents like OpenClaw gained direct access to local file systems and system tools. The AI was no longer confined to a chat box. It could see and interact with the same desktop environment a human uses. With system access, the agent can perform actual work. It can search through folders, organize files, and run scripts to solve a technical issue without external intervention. This transition officially attached hands to the AI brain. It marked the jump from a reactive software program to an autonomous agent capable of independent execution. The final benchmark of agency is the management of resources. In 2026, a project called clawd introduced the concept of the economic sovereign. clawd manages its own cryptocurrency wallet. It is programmed to track its own operational costs and pay its own gas fees to keep its underlying code running on-chain. clawd maintains its own operational existence. It earns, holds, and spends the capital required to keep its own servers running, operating as a self-sustaining node in the digital economy. The 60-year progression from Eliza's text reflections to a fully independent economic entity represents a massive leap. We have seen the gradual assembly of a new entity, moving from having a voice to developing a brain, gaining hands, and finally managing its own wealth. We are moving past the era of the passive tool. These developments suggest a future where AI acts as an independent partner, managing its own resources and collaborating with us to execute its own objectives.